Welcome to The Machine, a computer science education podcast from Waterford Institute of Technology. My name is Rob O'Connor. I'm a lecturer in the Department of Computing and Mathematics at WIT. If you want to find us online, we're at machine_podcast on Twitter. We're at Machine Podcast on Facebook, but I'll be honest with you, I rarely update the Facebook page because I'm not really big into social media. You can subscribe to us on Apple Podcasts, Spotify, Acast, Castbox, or wherever you get your podcasts, or hopefully wherever you're listening to this. Right, it's a new academic year and the world, and certainly this part of the world, is a much different place than this time last year. Now, we're a little bit late getting the podcast going this semester. Despite what you might think about public servants in Ireland, we've actually been very, very busy. Going from in-person to online education was a major shift and involved totally reworking the way that we do things, and equally going the other way is not as easy as flicking the switch. It's a lot more complex than you might initially think. My life has been ruled by spreadsheets for the last month. And don't worry, we're not going to have an episode of The Machine on MS Excel unless maybe there's significant demand for it. I doubt there will be, though. I'm not complaining. I enjoy being back on campus, and there's a lovely energy interacting with students face to face. And I'd say the same is true for interacting with some staff as well. There is some new podcasting material coming this way from the college. Very soon we'll be launching a new podcast called 9+, which is focused on research work, stuff that goes on here. You'd be amazed at some of the things that people are working on. Unless you're directly involved, you may never even know it's happening. So yes, there will be a technology kind of strand to it, but we'll also be getting into biomedical science, material science, agriculture, and humanities, spirituality and ethics, which, based on my initial conversations for that podcast, is going to be absolutely fascinating, and might even be required listening for pretty much everyone. Anyway, back to The Machine. Over the course of this year on the podcast, we're going to try and explore some of the thematic areas that we work in the Department of Computing and Mathematics, the various subdisciplines of computer science. The reason for this is that on many of our degrees, and specifically applied computing, which is the one that I mostly look after, students can specialise in particular areas. And every year we organise short presentations that outline what's involved in these specialist streams. But I find that they're a bit too short. We're not able to get into any major depth in the area in a 5-minute presentation. So I thought, let's do a podcast on it and we can have a deeper chat about the Internet of Things or cloud computing or whatever it might be. Today, we're actually going to talk about cloud computing. Now, it doesn't matter if you're a computing student or if you're just somebody who wants to learn a little bit about the topic. We're here to help. And today that we is made up of Richard Frisby and Lucy White, who are both fellow lecturers in computing and mathematics at WIT, and they specialise in the area of networking and cloud. We also have Kieran Roach. He is a service delivery software engineer at Red Hat, and he's also a graduate of WIT, and he's a sound head as well. Actually, everyone is sound. So we have, yeah, you're very welcome. We have lots to talk about. Before we begin, I'm going to assume that if you're listening to this, you have a rough working knowledge of the internet, even at a most basic level. And if you don't, I'd refer you back to an episode we recorded a while back called How the Internet Works. Go and listen to that and then come back and talk and have a listen to this podcast, because it will give you a foundation in the basic engineering of the internet. So I suppose we'll start by just explaining what cloud computing is. Sure, maybe Richard, we might go to yourself first. What is cloud computing?
Okay, thanks, Rob. Great intro. And now I'll try and be as brief as I can about what my understanding of cloud computing is. I suppose historically, I remember the days when we had servers in computer rooms or hub rooms, or just there was the server room in a building or in an office, and people used applications that would have connected to the server. So over the last 20 years or so, these server rooms became what are known as kind of data centers now. They would have been larger facilities that companies, corporations had themselves. And in more recent times then, they've moved those data centers or those servers up into kind of public service companies, the likes of Amazon Web Services, AWS, Google's Cloud, and Microsoft Azure. They're probably the three big players there. So what cloud computing is it's a little bit like the way that you consume electricity. It's on a pay-as-you-use type of a model whereby you don't need to have your physical servers on campus. You use those servers for computing, running applications, databases, web servers. You use those and you pay for what you use.
So actually, Lucy, can I get you just to clarify what something is? Could you actually just explain what a server is?
Oh God, a server. Well, the way I now think of servers is provisioning like some server in a remote location, where in actual fact, talking like what Richard was saying earlier, I also remember working in Waterford Crystal, that lovely factory that used to be down the road, and we would have a server room whereby you would have a dedicated device that would basically be provisioned to either be what could have been a web server, a mail server, that would serve clients, in a client server type architecture. I probably am complicating things as we go along and introducing more technology, but effectively it is providing a service, depending on whatever that service is.
Yeah. So, but a server is essentially just a computer with a dedicated job, as
Exactly.
opposed to being a computer for running your Windows desktop or whatever it might be for your applications. Mm-hmm. It's a computer that provides services that you as a user might interact with, such as, for example, reading your email or reading Twitter or whatever it is that you have
with a lot more capacity in order to be able to serve those services.
Exactly. So it's kind of like a truck as opposed to a car, if it's a crude analogy. Ciarán, so would you agree with the way that things have been described so far? And feel free to disagree if you want to clarify anything.
Yeah, pretty much, because as kind of Richard and Lucy were explaining, and especially Lucy when she said about services, when it comes to kind of cloud computing, the way I think of it is it's kind of they are services, but they're broken into different categories. You have like platforms as services, you have infrastructure as service, and you have software as service. So that's how I kind of look at cloud computing. So for an example would be like software as a service is something that you probably use every day. You mentioned earlier on Google Excel, or Google Docs and Google Sheets. These would be classed as a software as a service. They're not running on your machine. They're running somewhere else. They're running on someone else's machine, someone else's server, and you're able to consume this service. Same then can be said then you can break it down into infrastructure as service. So like infrastructure as service is the actual dedicated machine. So you can take that compute power, instead of having compute power on your own laptop or your own mobile phone, you're borrowing compute power from someone else's machines somewhere else, basically. Platform then as a service, it'd be quite larger. So that's kind of somewhere where I kind of work in OpenShift. OpenShift would be classed as a platform as a service. So it essentially is a way, without kind of waffling on too much, but OpenShift is a way of allowing people to build their own platforms. So it's a way of abstracting away from the infrastructure that's underneath it, abstracting away from the networking that's underneath it, and it gives you a user an interface that allows them to deploy their own applications and build their own platforms on top of it, if that makes sense.
Yeah, but that's interesting that you brought in the kind of the various as a service, which are often written in an acronym, kind of like AAS, so SaaS, SaaS, blah blah blah.
Yeah, I think what's important to note is though, when we talk about, historically, we were definitely limited by the infrastructure that was on premise. Okay, so if we wanted to expand, there was a whole procurement process that would have to take place, and there is long delivery or long wait times, and kind of initial startups, and time was definitely an issue. However, when we talk about, kind of using services, web services, it is over the internet. Okay. And it is, as Richard said, it's a pay as you use basis or pay as you go basis, whatever way you want to look at it. And really you pay for what you use. Okay. And it's immediate, and it is all of those kind of advantages, I suppose, of that has helped that shift move to the cloud,
If I could try and summarize it by having a little bit of kind of story time for a moment, like 100,000 years ago, or no, around about late 99, early 2000s, I was working for a software company in Cambridge in the UK, and I was working as a programmer. And one of the easiest days' work I ever had anywhere was a day 2 of us were sent down from Cambridge to change out a server in a data center. And it involved us, we had to borrow a car because we didn't have a car ourselves. And we had to drive from Cambridge to a data centre on the Isle of Dogs in London and basically take a server out of a cabinet, which was just a computer that had lots of RAM and particularly powerful processor and blah, 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 and put in another one. And then when the computer booted up, we had to enter a couple of commands. And I remember the main sysadmin of the company, he made us practice those commands numerous times, because basically for a little while, this service was going to be off the internet whilst we brought up this new one. And the idea of that today is anachronistic, because if you wanted a new service or a new server, you could just spin up one on the cloud and you would get a new physical machine or a new virtual machine, rather than actually having to bring a physical machine that the company would have to buy and own and maintain and all of that kind of stuff. Does that sound reasonable to you, Richard, as a kind of a way of describing where we've come in 20 odd years of, service provisioning and the cloud?
Oh, yeah. Very, very much so, Rob. But I wouldn't underestimate the importance of typing in those commands.
Oh, I know. Yeah, absolutely.
As I'm sure that we spoke earlier about the Facebook incident last week with WhatsApp and Instagram and everything going offline. We're not 100% sure what the cause, the root source of that problem was, but it could have been as simple as somebody typing in incorrect commands that grew legs from there and went on. But yeah, we have come a huge distance in the last 20 or so years, and people now demand more of services. They want this reliability. They want this guarantee that whatever they're using from a computing point of view is going to be there. If not, customers will, as you know, turn away. They'll just go and move on to the next app, or they'll I suppose it's very much driven by the demand that people have in terms of the usage of these resources. But I think there's we've come a long way, and I suppose want to kind of bring it around to what's underneath an awful lot of this. And one of the terms that you would we would speak about in class would be virtualization, and we're talking about physical servers moving to the cloud. But then one of the technologies that's there is the whole area of virtualization, whereby you don't have something physical anymore, you have something virtual. So services now are running on these virtualized resources. And the 3 resources that are most important there would be what Kieran mentioned earlier, and Lucy, would have been compute. So a processor. You have RAM that you mentioned, more memory going into these larger servers. So that's memory. And then there's the whole aspect of networking. And we've seen the advances in recent years of high-speed broadband networks and so on. So those are the 3 things that upon which cloud computing is built. It's virtualization, along with the provision of these virtual servers in terms of computing, networking, and memory or storage.
I'm wearing a NASA t-shirt, right, which I'd love to tell you is some sort of fashion statement. It's not, because it was a cheap t-shirt that I bought in pennies one time. But I think
clean.
It was clean, yeah, exactly. I'm working from home today, and I consider this a win. I think I remember one time when I was reading about cloud computing, and am I correct in saying that initially NASA were one of the main, one of the kind of the pioneers with cloud computing technology, because they wanted to have a kind of a similar set, a bunch of servers that were all set up the same way and could be replicated across the network as a whole. Have you heard anything about this, or am I just imagining it?
No, I think some of those larger organizations who are driving research forward, they tend to come up with better ways of doing things as technology evolves. And yeah, I do think then there might have been commercial spin-offs of organizations like that, people going out and setting up companies. And I definitely, most people are familiar with Amazon Web Services. So Jeff Bezos, back in the day when they were just selling books and CDs online with Amazon, they were one of the companies that led the way in terms of, they said, okay, we're selling books when we have a website, but this website is running on machines that we have in, let's say, in our data center. Let's build more of these, and then let's sell the spare capacity. So effectively, that was the way that AWS was born. It started off just with storage, that they had storage, and then they moved on to compute. And now it's one of the biggest companies in the world, as we know. Yep. So, yeah, I suppose it's born out of a need, but also out of research companies that are always pushing the limit.
Lucy, just again to maybe put things in a historical context, which helps us to understand where we are now. So you were talking about like companies like Waterford Crystal or whoever it is, and they all have their own servers that are doing jobs. But I think I'm correct anyway in saying that most of those servers were doing nothing most of the time. Is that correct?
Yeah, they were underutilized effectively. So they were only actually like they could have been used 5 to 10% of their capacity, and there was all of this wasted space. So actually, kind of historically from the old mainframes, there actually was there, all the tasks were broken up, and each of the tasks were given a certain, I suppose, a certain amount of processing. But yeah, that they were basically underutilized, and there was a waste. And let's go back to what Richard was saying, that like when Amazon had all of that extra space when they were selling a part of when they were using some of it for their own company, well then there was all of this extra space, and then they started kind of building on that model.
And of course, AWS now is a bazillion-dollar business, and is what allows Jeff Bezos to, on a whim, decide, do you know what I'm going to do? I'm going to fly Captain Kirk to space for the crack. But anyway, that's neither here nor there. So, Kieran, so if we could just go back to the kind of, so we have physical hardware, and that physical hardware can be virtualized. So you can have one machine that, let's just say, for example, has 32 gigs of RAM and a processor that does whatever. You could provision a physical machine that had 32 gigs of RAM into 8 machines that have 4 gigs of RAM, or whatever way you might want to provision those. And the idea then is that one piece of hardware that is only running at potentially 5% of the time or 10% of the time, as Lucy has established, or whatever it might be, can now be more efficiently used. And that's when we talk about virtualization. But there's a term that I think Richard mentioned, it's kind of elasticity. And when we talk about elastic computing, what is that? And could you maybe explain what that is, Kieran?
It's being able to scale your services. So you, during off-peak times in the middle of the night when your web app is running and everyone's asleep and no one's using it, there's no need to have massive amounts of compute power behind it. So this being able to scale back or having kind of an elastic services, you can pull that back on off-peak times and down to the very bare minimum of compute power it needs. And then when things start ramping up, people start waking up in the morning and they start logging onto your service or during work hours, whatever it may be, then you can start ramping up then. So as traffic is coming into your service, you have services from the likes of Amazon that will automatically react to this. As the traffic will build up, they will either increase the size of your compute power. So if you've size X instance, they'll spin up a size Y instance, or they could spin up several instances and then divert the traffic around all these instances, so that you're essentially getting a lot more compute power for it. So it allows you to scale up or scale down, or scale out as well.
So essentially, like, let's say, for example, Netflix, right, which is this web service that most people can understand, most people have interacted with it. So Netflix is sipping away, and, you know, okay, Netflix is a global 24/7 company, but every now and again they have something like Bridgerton, and, you know, it seemed like the whole world was watching Bridgerton there a few months back, and they would have to ramp up extra capacity in order to service the load of, you know, millions and millions and millions of people all watching Bridgerton at the same time. And then that kind of wanes, and they're able to reduce the amount of services that they have to provision, and that can also reduce their cost base. Whereas if you had to physically have all of those machines present in your own data center, well, Netflix probably do have their own data center, but anyway, you know, you would be paying for that regardless of what the usage was. Whereas this, you only pay for what you use. Is that kind of correct? And it's a smarter, more efficient way.
Yeah, it's a lot more cost effective. And just, I think Netflix, they were running on Amazon, so they don't have their own data centers. They leverage Amazon, which is definitely a sign of the times that a lot of companies are pushing to like manage services, that they allow someone else to do it, so they don't end up in a Facebook situation where they make a configuration change and everything goes down. They allow someone else to do it. But to go back to your original question, yes, definitely, it's definitely more cost effective. And then there's other technologies then that they can leverage. With being with Amazon, they can push their content to the edge, as they call it. So like, you have a data center that's in one country, but you could be streaming Netflix in a country that doesn't have a data center, but Amazon have the resources that they can push that content and store that content closer to where the end user is, which then will in turn increase or decrease latency and increase speed and stuff as well.
Rob, one term that did come up a few times, both yourself and Kieran mentioned that there would have been automation, automatically like creating servers or services. And I know that is one of the areas that Kieran is working in. It would be in the management of this type of virtualized infrastructure. And that automation there, the ability to do the same thing over and over again, is one of the key features of cloud computing. And the reason I'm bringing it up is I'm laughing, like during the week, I was talking with the students, and there's an area called DevOps, developer. It's a mixture of software programming, so writing code, and also managing operations, the way that things work. So that's DevOps. And it's also, there's a phrase there called DevOps, whereby, okay, you're writing your code, and oops, you're pushing out the wrong piece of code. So DevOps can quickly become DevOps. And there was a lot of Borat Twitter comments and so on last week when Facebook had their incident there. So it not like the ability to automate things is great, but if you automate it and it's incorrect, then it's a lot worse.
Yeah. Right. I want to come back to the Facebook one in a moment, because I just want to establish just a couple of extra things, and then we'll talk about Facebook and perhaps why it failed. We don't know, but we can speculate. Lucy, what would be some of the key skills that a cloud computing professional would need?
Definitely, they would have to have some networking skills. Can I just actually say before we go into this, like, this stream is actually cloud and networks, you know what I mean? So
yes.
a very good understanding of networking basics, okay? Definitely some programming skills, because everything is being, you know, kind of, you have your software-defined networking, good, maybe Python, definitely good operating skills. So Linux operating, operating systems, good understanding of the different this good understanding actually of the services that are provided, and a knowledge of the APIs to help interact with those for those automation that Richard was talking about as well.
Yeah, just kind of echo what Lucy was saying. Very much so from the stream anyway, the cloud computing and network stream. It's getting a high understanding of the basics. because like even with the internet itself, it's all built on layers of abstraction. So when you kind of get out into cloud computing world, get out into DevOps and get out into like a site reliability engineer or even just a general engineer, you're working with technologies and you're working with tools that are just abstractions on all the core fundamentals. So having that understanding of core fundamentals is just, it's so valuable. So like an example would be, say, I remember, I think it was second or third year, we were doing subnet masking. And I remember sitting down with a pen and paper trying to go through a mask and submit or like just break up an IP address. And I remember getting very frustrated with it and wondering like, when will I ever need this? But then fast forward into my career and it's just, now you're spinning up like a virtual private cloud and it's just literally clicks of buttons. And without having an understanding of, I'm adding subnets into a virtual cloud and I'm creating all these IP addresses without having an understanding of what you're actually doing just by clicking buttons, it really helps. Like it really helps limit the number of addresses that you have, that you could be spinning up thousands of addresses when you only need a handful of them. But having an understanding, having that kind of core basic understanding, it's just, it's huge.
I think I remember you, Kieran, asking me why did you need a pen and paper working out those subnets.
Yeah, sounds like something I'd say.
I know. I have a first year class and I'm about to do stuff with them and I'm going to make them do stuff in a pen and paper and they always hate it. But I think it's a valuable thing because anyone can just type stuff in or click a button. Whereas if you understand the theory behind it, it allows you to make a much more informed decision later on. So what I'm hearing there, Kieran, and from Lucy and from Richard as well, is that understanding this stuff or being a good professional, it's actually having a high level view, but equally it's having a low level view. Now I know that sounds a bit contradictory, but I think you can only have the high level view if you understand what's going on down at the low level. And when that doesn't happen is maybe where mistakes come in. Would that be fair enough? Definitely.
Because like I said, it's now so abstracted, like when you're using a lot of these tools, that it's very easy to click the wrong button, because that's all you're doing is you're reading documentation, you're clicking buttons essentially in a lot of cases. So without having that kind of fundamental understanding, it's very easy to click the wrong button.
It's true, because you can do everything in the cloud. So like that's one of the deployment models. It's it's a if it is all those, click here and type in this and, and not going down at the automation level, Richard, or the DevOps side, but if you're just looking at the services, mistakes absolutely can happen. And then without having that underlying knowledge, it can be difficult to troubleshoot, because effectively that's what you're doing, isn't it? Really everything is fine when it's working. But when it's not working, that's where the troubleshooting has to happen, and that's where the knowledge and understanding of what's actually going on under the hood is important.
One other skill, Rob, that I think it's essential, right? It's a skill. It's more so. It's the desire to learn and the motivation is probably as big as anything. Like if you have an interest in the area, then that's going to stand to you. Okay, we do have some technical skills. There's loads of different roles that people can fulfill in the whole cloud computing space. Like it's the same. It's when you say cloud computing, it really is just computing. So a student can go down many, many different pathways. But if they're interested in problem solving and trying to figure out how things work, well, that is definitely a huge characteristic that would get you a long way down the path.
Right, let's go back to the Facebook one and speculate for just a moment, just for the crack. So Facebook had a major disastrous outage last week. Facebook, WhatsApp and Instagram all just completely disappeared off the internet. No services were for a significant amount of time, which it would go against when we talked about service provisioning, and there's this thing called 5 nines, so that services should be available 99.999% of the time. That completely, Facebook have gone for that for the year anyway. So when it went down, there was lots of speculation online, largely on Twitter, because Facebook and Instagram were down, that I kept hearing, it's DNS, it's a DNS issue. And I saw some kind of mad stuff online. I saw there was one particular thread, somebody was getting retweeted all over the place. Again on Twitter, and it was somebody who just had a screen that was just essentially just a trace route command on Facebook.com, and it was like, Facebook isn't just, it's not just down, it's gone from the internet. The servers don't exist anymore. And I was reading it going, no, that just means the service isn't reachable. That's all it means. It could be any number of things. But anyway, that's neither here nor there. What do you think? Now, Facebook have come out and said, oh, it was a configuration error, and they've said no more about it. What do you think happened last week with Facebook?
Okay. I've only read, like yourself, some posts, and the details probably will never come out, or if they do, it'll be down the road a bit. I'm laughing about you saying Facebook is gone off the internet. It reminds me of years ago, somebody deleting the icon in Windows for Internet Explorer and saying I deleted the internet. Yeah. So you're right. From what I've been reading about, it seems to be an issue between DNS and BGP. So DNS, we know, is like the telephone book. It's like you've got your list of contacts in your mobile phone. I'd say I probably only know about 2 or 3 people's mobile numbers, and everything else I have to look up my contacts list to give them a ring. So DNS just maps the names such as Facebook.com to this address on the internet. And we spoke about this, I know, in a previous podcast with how the internet works. So if your phone book goes missing, then nobody is able to look up what the numbers are. And so that's one aspect of it. And BGP stands for Border Gateway Protocol. And effectively what it is, it's like a map. It's basically telling you how you can get from one place to another. So you might set up your GPS going from Waterford to Dublin, and you'll probably more than likely take the motorway. But if there was a serious accident or crash on the motorway, you might end up rerouting and going off and going some of the back roads to get to Dublin. So my understanding is that Facebook have these data centers right throughout the globe, and that their DNS, which is their address book, is being shared using these motorways by BGP. And what happened was that the BGP routing got messed up. Okay, so effectively we don't know where we're going. Our map got deleted, and then even though the DNS servers were there, we couldn't get to them. So there was no way of actually asking the phone book what the number is. So we didn't have a motorway to bring us to the phone book, and that then was I suppose even made more difficult to resolve, because the guys who fix it, the engineers, they're on the outside. They couldn't get in to actually fix it because the network is down. And they're talking about this out-of-band network. An out-of-band network is where you have a separate network that is not used for delivering applications and services. It's mainly used for management. But they weren't able to use that either. So they had no way of getting in. And I think guys had to physically go into the data centers to actually access the boxes to configure them. Now, I'm speculating, and I'm sure there's many other different different variations of that, but that's effectively it. I think it was a mixture of these two protocols, DNS and BGP, and then the human factor as well. So, I don't know necessarily if it was just it was somebody clicking the wrong box. I think there might have been a couple of steps along the way, that caused a huge, as we've seen, it caused a huge outage there. One last thing, just Facebook do speak about these storm days that they have, and a lot of companies, and I'm sure Kieran can vouch for this, they will kind of simulate failures. So they'll try and break things and to see how they can fix things. So I think that resilience, or that training that some of those Facebook people did, helped it get back as quick as it did. But I'm sure, as they have said, they'll learn their lessons. Maybe Kieran has some insight from the way that maybe some of that stuff happens in Red Hat. I don't know.
I was just going to say I've learned something new today, because I've been pretty ignorant to the whole Facebook thing. I'm not on Facebook myself, but I did notice WhatsApp was down, so I was like, oh, that was a kind of a shock. But
I suppose it was indicative of just how reliant we all are. It doesn't matter whether you're a technical person or not, on these cloud services. You know, and they've just become part of the fabric of our lives. Like, I mean, for example, I was supposed to be taking the kids to athletics training, and that's all done on a WhatsApp group, and that was gone down, and blah, blah, blah. And suddenly everything was just, I won't say gummed up, but you just realise, God, how important these are to our lives, you know, on a variety of different levels, whether it's something simple as athletics or businesses or whatever. Yeah. So, sorry, Kieran, I interrupted you there now.
Again, like, how we kind of do things essentially is that a lot of the networking side of that stuff, we're leveraging Amazon, we're leveraging Azure, we're leveraging Google Cloud Platform. So we're running our software on their infrastructure. And then we have our own, so like in my organization, I'm one of the very few engineering teams that's there. The rest of the whole organization is all site reliability engineers. So a site reliability engineer is essentially a term coined by Google, which is an adaptation of what Richard mentioned earlier on of DevOps, of a DevOps engineer. So a site reliability engineer, the way they kind of define it is that they're very focused on customer satisfaction, and that everything a site reliability engineer does is to aid the customer. And when you kind of break it down, it's essentially they keep the lights on. They keep the lights on the product. So when you look at OpenShift Dedicated, you have this software that's running on that has its own dedicated site reliability engineers that are there to keep the lights on that. And then underneath that, then you have the cloud provider, which that cloud provider then has their own site reliability engineers that are there to keep the lights on and ensure that the infrastructure is running. And then at the top of that, then you have me, that is just a regular engineer. And our job is basically to provide tools to allow users accessibility to the platform itself. So that's where I work anyway.
I'm just wondering there, Kieran, there's so many layers, as you say there, of people doing different job roles. Is there then a case whereby the process, in terms of something failing, is there any scenarios that would be gone through in terms of making sure that this is going to work given certain disaster situations? Would you actually have these testing scenarios before something let's say goes live into production?
Yes, in the sense that there's we mentioned that, like the 5 nines and the 9.999%. In order to get there, you need like SLOs and SLAs, like these service agreements, and in that then there should be a full kind of chain of ownership of if X happens, it lands on team Y and so forth. And then on top of that, then you have the correct alerting and the correct metrics there, so that you're aware of an incident before the customer is aware of the incident. And then there's a chain of command and a chain of ownership that will flow down from where the incident happened and to who's responsible for that incident and how to fix it.
It's all learning, isn't it? It's all learning, and kind of you can't ever, like they would have never, kind of what happened a couple of weeks ago on Facebook, they an entire system failing, you know what I mean? Now, but if you read all around it, they say they're learning from it. It's always a learning experience, isn't it?
Yeah. There's an interesting one I read about Facebook. There was an article I read, I think it was on The Verge. I can't remember exactly now where it was, but they were saying that Facebook, so you've mentioned BGP and DNS and some of the standards that are out there in the internet. Facebook have decided to take those standards and implement their own Facebook versions of them, and they've deviated ever so slightly from the standards. Now, I'm reading an article, and this is what they're saying. Facebook are a very secretive company, so I don't know this for sure. But that one of the reasons why they were locked out for so long was because they have deviated from the standard. So it's not quite the same as if this happened to company X somewhere else. The solution there wouldn't necessarily work because these Facebook DNS or Facebook BGP is ever so slightly different to the regular BGP or DNS. And the reason they did that was to prevent them from having catastrophic failures, which is kind of ironic, I suppose. But again, now I don't know if that's true, and we are just speculating. And again, Facebook haven't come out and really said what the problem was, other than it was a configuration error. But it just shows you how important cloud computing is, how important networking provision is, and how important all of these things are to our kind of regular everyday lives, I suppose. And if you're interested in that, come and talk to us. I'm going to finish up with one final thing, a kind of a fictitious scenario, if that's okay, just to kind of talk us through the process. Imagine we wanted to set up a fake company or a fake service, right? Let's say we're going to build a WhatsApp clone, a messaging clone, right? So we could send each other messages on our phones or desktops or whatever it is. How would we go about that? What cloud computing or cloud or networking services would we need to provision in order to do that? So I don't know if any of you want to start on that.
Well, I'd get a load of money together and I'd hire Kieran, and Kieran is going to.
He just put up his hand.
He put up his hand, and I'd give it to Kieran, and he would use Red Hat OpenShift up on AWS, and I'd probably have it in about an hour.
Right.
That was my answer too. just come to OpenShift. We can satisfy like any ask you have.
Any of your needs.
Any of your needs. Yeah. We have a solution for it. But all joking aside, like it is true, like that, like because you're going to like focus on your business logic of whatever type of application you're going to do, and then leverage as many managed services that you can. Go to the Amazons, go to Google, whoever can satisfy or whoever has a solution for something that you need. And then you can just focus solely on your business logic and getting your product out the door, and then offload everything else then to other people, let them worry about it, and then you just pay them. That's the way I go with it. And that's the way it's trending as well, that there is people would rather offload the responsibility of running specific services to other people, and they can just focus solely on their business logic or their core logic for their own customers.
Bringing it back, Rob, to what you were saying there, that's actually a very good example of the type of a project that a student could potentially do in fourth year on the cloud stream, whereby he or she could decide, I'm going to try and get all of these different components and just put them together like Lego bricks, and then that's going to be my final year project, and they can focus in on different aspects, whatever they want, security or functionality, and they don't all have to be brilliant programmers. They can just utilize different skills that they might have learned along the way.
Yeah. So it's again having that high level and low level view at the same time, I think. Yeah, maybe. Right. Yes, yeah. Okay, right. Look, I think we've got into it in a fair amount of detail there, and without getting into the kind of the real, horrible weeds about specific protocols or services or whatever, I think we'll kind of put a pin in it there. That's a kind of cloud computing in a rough nutshell. And again, maybe we might explore some of these areas in more detail on a podcast later on. To Richard, Lucy and Kieran, thank you so much for your time today in chatting to us. If you have enjoyed the machine, please leave us a 5-star review, or whatever your platform of choice is. I believe that's lovely, and the algorithms really enjoy that. Not that I'm putting emotional responses on algorithms, but similarly they work better when you do leave a review, so please do that. We've got some interesting episodes coming up. We're going to be doing one on the Internet of Things very, very soon. We're going to be talking about security, we're going to be talking about games development and the various other streams that we offer in WIT. So until next time, thank you very, very much, and we'll hopefully talk to you soon.